All right, and let's talk about HTTP post. So we're at the point where we have what I like to call the poster sites. We can build a static site with static content. Users can request that content, and we can send them that content. For Homework 1, this is just a purely static site. For Objective 1 and Homework 2, it's a little bit flexible in that we can send a query string and serve up specific images based on that query string, and then have a little bit of dynamic content, including the user's name on the page that we serve. But that's, pretty basic. That's not a lot of interactivity. That's still just static content, but the user has a lot more flexibility in the static content that they serve, that they get. And I guess the name is a little bit dynamic, but what we really want is apps that people can use. We want to build web applications, something we haven't done yet. That's what we're going to start doing, the namesake of the course, instead of web pages. Why do we call this web applications? It's an actual app running on a server that users can interact with. The most basic form, the one I like to use for lecture examples, is just a chat app. People being able to chat back and forth. Users interacting with other users, where all of the content is dynamic, and your server is managing that data and sending it to other users. That's what we want to build. Users interacting with our site. So today we're going to do that with forms. We're going to see different ways of using HTML forms to get information in different formats to our server. So HTML forms. Here's an example of a form. We'll go through this step by step. But this is going to let the user send information to us. I'm sure you're all familiar with forms from the user end. Now let's talk about what happens on the server side with these forms. So when the server gets a request from an HTML form like this, it's going to send an HTTP request. We're going to send an HTTP response. And it's going to work just like somebody typed a URL into their bar, into their navigation bar, and hit enter. This form right here specifically, it's going to be exactly like that, exactly like somebody typed something into that into the URL bar. Hit enter, and the important thing here is that it will trigger a page load. It will reload the page with whatever you send back to the user. So if somebody submits this form, you get that request, you send back a response. That response is just like a brand new request to your page. It's not in addition to the current page that's loaded. It's going to load a whole new page. And you see this on the internet. Most forms will, I shouldn't say most. I mean, we're getting pretty dynamic now on the web. But when you submit, it's going to take you to another page. It's going to refresh the page, reload a new page after that form submission. And that's the default behavior. Of course, there are forms that don't reload the page. And that's later in the course. We'll do that too. But this form right here, somebody submits using this specific form, they're going to get a page reload. So let's take this apart, look at each piece of this, and see how this form is formulated. First, the form element itself is going to have several properties, or attributes, sorry. And the two most important ones are action and method, where action is going to be the path that's going to be requested when somebody submits this form. Somebody submits this form, you on your end, on your server side, you're going to get a request where the request line has a path that's going to start with form path. So we get to specify the path, which helps us parse on the back end, on the server side. We see a request, we're going to look at the path and know, oh, /form path, somebody submitted this form, most likely, or they destroyed our front end and sent it by other means, but they probably use this form. And then the method, either get or post. What's the method for our purposes? What's the method that's going to be sent? So somebody sends this form, you're going to get a GET request for /form path. Yeah.
Sorry, for the form path and whatnot, do we need to have form in the name? Or is that just
no, it's whatever you want to name it. Yeah, the path, I put form here, just, it makes it clear when you're parsing, if it's form something, just to name it something meaningful so it makes sense on the back end. But it can be whatever you want. But it helps to have it something meaningful, just so your back end code is more clear, more self-commenting. And then we use inputs in the form to allow the user to send us, to input information. I don't really have a way of saying that. It's pretty, speaking of self-commenting, this is pretty self-commenting. To input information to you. So this is going to be an input form with an ID of form name. Type text means, actually I think I have that on the next slide. No. Type text, we'll talk more about types, but let me just mention that. This is going to give us a text box where somebody can type in any text that they want. And the name is going to be very important for us. The name is what this input is going to be called on the server. When we get this request, whatever we put as name for an input, that's how we're going to identify the data associated with that input on the server side. So this input right here, we're going to get some information with an ID of, with a name of commenter, and then the value that the user typed into that field. That's what we're going to get on the server side. And then I have labels associated with these. This is the only reason I use the ID attribute. I'm going to use an ID and then 4 in the label. This is very important for accessibility. I know we don't talk much about front-end stuff, but this one's pretty important when it comes to forms. You really should have a label for every single form that you have if you have any information associated with that input. So this input is me asking the user to enter their name. I could just put the text, enter your name, right next to the field, and then when the page renders, I'm going to have that text right next to the form. You know, people are going to get the idea. But not in all cases. So for example, if somebody's using a screen reader, the label with the 4, make sure that that screen reader reads that input as part of that, reads that label as part of that input. So for example, if somebody is potentially blind or can't see that text is right next to, physically located next to this input, and they're relying on that screen reader, the label tag is going to let them know, hey, this is associated with this input. It allows them to use the internet, makes the internet more accessible. It also helps, you can tell when a website doesn't use these labels, and I get mad at them every time a lot of UB apps that I have to use don't do this. When the page loads, click on the text, and if it doesn't select the input, then they didn't use these labels properly. Those aren't associated. But whenever you have a lot of radio buttons, and you want to check one of the items, and you don't want to check the little circle itself, you click the text next to it, and it selects the circle. That's because the dev used a label and has that label associated with that input. So it's nice, not even just for accessibility with screen readers and things, but even just regular use of the internet. It makes things a little nicer to use. So when you're developing your web pages, it's nice to have them labels. And then a special input of type submit. The value for the submit, this is going to create a button, and the value of submit is going to be the text on the button. So this form is going to have a button that says submit on it. Then when you click that, it's going to, you guessed it, submit the form and fire off the HTTP request to the server. And then finally, on the server, when somebody submits this, because we used a method of GET, this is what we're going to receive on the server side. There's no body to the request. All of the information that's put into the form is going to be in the path itself in a query string. So if we use GET, and by the way, just to foreshadow a little, we're going to see 3 different ways to send information through a form. The third one is the one that's going to be most important, the one you're going to have to use. The other 2, the first 2 you can use if you'd like to work with them, but the third one you have to use. So this is the first one, a method of GET. It's going to send all the information in a query string. It's going to be URL encoded, so we're going to see percent encodings. I said good morning, exclamation point. The exclamation got percent encoded as a %21. And we're going to have the key value pairs. The keys are going to match the names of our inputs. Whatever we named them, that's whatever you want to name your inputs. As long as you're consistent on the front end and back end, that's how they're going to communicate. And then equals whatever I typed in this field. So in this form, in the commenter input, I typed in Jesse. In the comment input, I typed good space morning exclamation point. And the space was encoded with a plus for what it's worth. I would prefer %20, but that's just the way the way things are. So we got that information in the URL itself. So when I said this is just building the URL, it's the same as somebody typing in a URL. This would be the URL, your host path, host port slash, then all of this. Typing that in and hitting enter would be the exact same thing as submitting that information into this form. All right. Any questions on this so far? All right. But that's very limiting. When we're using get requests to send information, that's really not what we are supposed to use get for. When somebody's sending information to the server, we want to use post request. So post request is going to solve our problems here. And of course, it's the big title slide of this lecture. You better be expecting some post requests. There are a lot of limitations to get, besides just being kind of gross, having all that information in the URL and parsing query strings and then de-encoding the percent encodings and stuff. Besides just being gross, there are actually limits to this. Browsers and servers will have limits on the length of a URL and on the length of an HTTP request, the HTTP request headers and responses actually. The length of the entire header section, which includes the URL, is limited to usually just a handful of thousands of bytes of information. Not a whole lot. I mean, it's good enough for headers, but it's going to prevent us from sending like good amounts of information in the headers. What if I have a 5 megabyte image that I want to upload? Not doing it like this. Not doing this with a GET request. We're going to have to use the body of a request and do things that way. Or else some servers will, and I've mentioned this in an earlier lecture, I keep getting in the hub denied because my headers are too large and I have to delete my cookies because it has this really huge cookie it keeps setting. That's this limit being hit. The limit on a GET request, including all the headers, if a site is abusing cookies and sending really huge cookies like the hub does to me, you're going to hit that limit and the server is going to reject that completely. The servers or browsers, both ends are going to have limits, and you're going to hit those limits pretty quick. Yeah?
So to avoid those limits, we would just do multiple.
But we're going to use post request. Post request is going to save us there. Okay. That limit's only for the headers. Everything after the headers, which is going to be in the body can be unlimited size. At least HTTP itself has no limit, and I think most servers and I mean, maybe there's a limit, but it's going to be like astronomical. Right. It's going to be ridiculous. So all these problems are going to be solved by post requests. Post, this is when we want a user to send information to us. We're going to use post requests, not GET requests. GET requests are strictly for getting information. If you're using GET requests to send information, you're kind of abusing what a GET request is supposed to do. You really should start switching over to post requests. There is kind of a what do I say, a rumor, folk tale, I don't know what to call it, but there's information, I'll say, floating around there that use post requests for security. I want to squash that one. Post requests don't add any security. Don't believe that. If anybody tells you that. Use a post request that hides the information you sent. No, it doesn't. It just puts it in the body of the request, not the URL, not in the path. But post request is going to give us a lot of nice features when we're sending information to a server, when we want our users to send information to us. And for this, it's going to follow the same structure, protocol, I suppose, the same structure as our HTTP responses. When we respond with our HTML, we respond with an image, we respond with whatever we're sending to the user in our responses. Well, now when we have post requests, we're going to receive information in that same format with that same structure. Most notably, there will be a body of the response following a blank line. There will be a content length, and there will be a content type. So we'll want to read those headers to figure out how to interpret the body of the request. So we're on the other side of that. We know how to write these responses with bodies. Now we're going to get requests with bodies. We're going to see, how to parse them instead of write them. So we'll be on the other side of that token. So to parse a post request, the first thing you want to do is look for that /r/n/r/n. Look for that sequence, and that's where you know it, that then you know that that's where the end of the headers are. Once you see that sequence, you know that everything before that is headers in the request line. So you can start parsing the headers and request line. One thing we know about headers in the request line, it's ASCII only text. So everything before that blank line, we can decode as ASCII and parse it as ASCII, parse it as headers, everything you would do with a GET request. With a GET request, you didn't have to worry about anything after that blank line because there was always nothing. There was no body to that request. With a POST request, you want to ignore what's after that blank line for a bit until you parse the headers in the request line to figure out what you're parsing. And we'll talk about this more when we talk about image uploads, but what's after that blank line might not be ASCII or UTF-8, it might be an image. So if that's an image, you don't want to parse it as a string. Just like when we were sending images, we wanted to make sure we never encoded it as a UTF-8 string. Now when we're receiving bytes, we never want to decode that as a UTF-8 string if it's an image, if it's not UTF-8. So we have to look for this blank line in the world of bytes and then split, take everything before that sequence, parse the headers to figure out what everything after the blank line is, and then parse the whatever's after. If that happens to be an image, just take the bytes of that image. Well, we'll get to this, but take the bytes of that image and then save it to a file without interpreting those bytes as anything, because we're not in the business of decoding JPEGs or PNGs or anything. We're not in the business of those file formats. We're going to treat them as bytes and just save them to a file. Yeah.
Just out of curiosity, since we can like read the number of bytes at a certain point, like, do we need the content length? I know it's good to have, and that'll be more practical, but like.
Yes, you need the content length.
But like why? Like, couldn't you do it without? Because like, couldn't you like at a certain point be like, okay, after this, read how many bytes are in this content, and then.
And how do you know how many bytes are going to be in that content? So the problem we're going to face here is when we get more data than the size of our TCP buffer. So like if you're using Python, you have that number, you have read, this many bytes of information. It's usually like a K or two by default. Well, what if I have a megabyte image that I'm uploading? You're going to get the first 1K bytes. You're going to say, I'm not reading content length, I'm just going to take whatever I got. Well, all you got is like 10% of the image, or 0.1% of the image, to go with my numbers I just said. So you have to read the content length to see if you have to read from the buffer again, read from the TCP socket again, and then keep reading until you read that many bytes. And we have a whole lecture on buffering, but that's the important reason why too. People who aren't buffering and trying to just get away with that, they're always in office hours. I like it because it's an easy office hour question to answer. But they'll say, when I read the request, all I get is the headers and I don't get the body at all. If you ever see that, it's because you're not buffering. It's because you're not reading content length and things like that. But we'll talk about that more when we get to image uploads and buffering. Because for text, for this, you don't have to do any of that. You could just read the whole thing and get away with it. But once we do images, a lot of browsers will send the headers over the TCP socket and then send the image. So when you read the first time, you're only getting the headers. And then you read another time, then you're getting the image. So cases like that too. You might not even be buffering. You might have a very small image, just a couple of bytes even, and you have to read content length. So. All right, so let's do post requests. Very simple. We're going to change method to post instead of get, right? Hey, the front end side, not too much content. Even the back end side, like how we're getting this information isn't too complicated. It's when you sit down to parse this stuff. That's where the difficulty is going to come in. In next lecture, by the way, I'm going to switch Wednesdays and Fridays lectures. So posting images is going to be Wednesday's lecture instead of Fridays. Because this stuff leads right into that. And that's where we're really going to talk about parsing this stuff, how we're going to handle these requests. So we're going to change the method to post. And now we're going to get our first post request. So when we switch that to post, we're going to get all of the information that would have been in the query string in the body of the request. It's still going to be URL encoded, which I don't know about you, but I don't like that. So it's still going to be URL encoded, but it's going to be in the body of the request. We're also going to have content length and content type. In this case, the content type is going to be URL encoded because that's how we're going to get the information of the body. The content type is going to tell us that this is URL encoded information. We're going to have percent encodings. We're going to have query string syntax. We're going to have all that. This would be fine. This and the first way of doing things would be fine for Objective 2, where it's a text form. You would be able to get away with that. You still have to deal with URL encoding, but you already did that for Objective 1, so you should have that code. You should have generic code that parses query strings, and you can throw that code at this and then parse this too. And this is kind of a lot of the conversation we just had, actually. But we have to read that content length to know how many bytes to read that many bytes after the blank line, and then parse it according to the content type. Honestly, you'll get away without reading content type in this class. I don't like advertising things like that, but I have been so far this semester, so might as well keep going with it. Because you're going to read the path. You're going to say form path. Well, I know what I'm expecting on form path, and you're going to write your code to parse whatever your type you're expecting based on the path. But if we had a path that takes multiple different content types, we'd have to read that, which, now that I say that out loud, should be an objective in a future semester. But anyway, that's how you're going to get the information that you need to be able to parse this thing, read the body, and then decode it the same way we decoded query strings. But query strings are gross, or we don't want that URL encoding, percent encodings. We don't want that stuff. Plus, do I have it on the slide? When do I talk about that? I guess I'll just talk about it right now offside. But plus, if we're using this format, URL encoding, how are we going to send an image? How are we going to have our users upload images when we get to objectives 3 and 4? I know I have that on slide, I just don't know which one. Anyway, maybe it's a lead-in on the images lecture. But how are we going to send an image like this? Now, we can do it, but we'd have to percent encode every single byte of that image and just send the bytes as percent byte, percent byte, percent byte. And in fact, the browsers won't even let us do that. Not going to let us do it. If we just have this form and we want to use this to send an image, it's not going to work. Just not going to work. So we need a third and final solution. We're going to change the encoding type to multipart form data. The default encoding type is URL encoded. There are 3 possible encoding types. URL encoded, plain text, which you should never use for any reason except possibly debugging, and multipart form data, which is the one that we're going to have to use if we want to send images, which of course we want to send. So when you're doing Objective 2, even though the first 2 methods will work, you just flat out get, flat out post, those will both work with URL encoding, parse the query string, parse the URL encoded data. Those will work for Objective 2. But since you have to do this anyway when you get to image uploads, I recommend doing Objective 2 using multipart form data. Write code that's going to parse any multipart request, and then use that code for Objectives 2, 3, and the rest of the semester whenever we have code, whenever we have forms with multiple pieces of data. Multipart form data. All we do is change that encoding type. Again, not much change on the front end, but significant change on the back end, on the format of the request. This, in Wednesday's lecture, we're going to go through this in excruciating detail and talk about how to parse this. More so just giving hints. Just seeing this format right here, you could sit down and parse requests, multipart form requests, but I will have some help in lecture. I used to just show you the format and say, you can parse this, but it caused quite a few issues, so I do give you some help with that these days. Anyway, you're going to get a request of this format. where the content type is now multi-part form data with an extra piece of information. So just like when we would send the content type and we would say text/plain char type URL UTF-8, just like we would do that, we're getting an extra piece of information on the content type. We're getting this boundary which equals some string, or rather some sequence of bytes that are not URL encoded. There's too many encodings. That is ASCII text, ASCII only characters in this string, or in this sequence of bytes, ASCII encoded characters. And it's important that it's bytes. We'll see that when we talk about image uploads on Wednesday. But we're going to get this boundary, and then we're going to get each piece of information from the form separated by that boundary. So we're going to split everything on that boundary, look for that boundary, get all the content in between the boundaries, and each piece of content in between the boundaries is going to have its own set of headers. We only have one each for this example, but its own set of headers and its own body. So it's just like parsing a request, except there's no request line. There's no post form path HTTP. Aside from that line, it's following the same format as a request, as an HTTP request. So we have any number of headers, except we don't have content type and content length either. We have content disposition, which is similar to content type, but it's going to tell us the name of the field that we're parsing to. So it gives us the type of the information and the name from the input from which it came. So here, our commenter field, I entered Jesse. Headers, blank line, content. We don't have content length here because we don't need it, because the content ends next time we see the boundary. So we already know exactly where the content's going to end. We already know the total number of bytes of the request. So everything after this blank line, if you want to sit here and count the characters, it's going to be 252 of them. At least I hope, now that I said that. Hopefully I didn't alter the slide after I pulled the request. 252 characters. We're going to read all those characters, and then we're going to parse. We're going to separate the parts by looking for the boundary, and then parse each piece of content based on looking for the blank line, parsing the headers, looking for the content. Blank line, headers, content. This boundary, this drives me nuts, but it's just part of the standard, it's part of the protocol. This boundary, when it shows up in your request, has 2 extra leading dashes right here. That's not a typo. There's 4 dashes in the boundary here and 6 in the actual content of the request. You have to add those 2 dashes. I don't know, I don't have a solid reasoning why, but this prepend 2 dashes to it and then look for that string in your content, and there will also be 2 trailing dashes at the end of the entire request. One really nice thing about this boundary, you notice it's long and it has lots of random stuff attached to it. This boundary, and the browser is going to guarantee this boundary is guaranteed to not appear anywhere in your content. So this sequence of characters, this sequence of bytes, will never appear in your content. So we can reliably look for this boundary and split our content based on that boundary without worrying about finding it somewhere in the form data itself. So somebody can't submit information with this boundary in it. The browser is going to guarantee this. It's going to look at the information that the user is submitting and make sure that when it decides what to use as a boundary, it's going to generate this based on the content that was submitted to ensure that it won't appear in the content. So that's something we have a guarantee of. The standard says, browsers, you have to do this. If they don't do that, they're not following the standard. And honestly, with this many random bytes, I mean, it's going to be pretty unlikely anyway that that's going to match. But the browser does guarantee that it's going to choose a sequence of bytes that do not match the content. So we can safely look for this boundary with 2 leading dashes, separate all of our information, and parse each piece of information separately. Now, at first, this is going to look like more work than parsing the query strings. But once you have the code, general code that parses multi-part form data, which I strongly recommend, write generic code that parses any multi-part request and returns the information, whatever information you want from that. Once you have that code, it's going to be a lot easier because you can reuse that over and over again instead of, you can kind of do the same thing with your URL encoded, but instead of dealing with the percent encoding, there's no percent encoding here because we have proper types in our content headers. When we start uploading images, there will be another header here that says, hey, this is an image. And then we can just use the bytes of the image instead of being restricted to ASCII only and then decoding and trying to figure out how to work with ASCII strings when we have an image. How are you going to upload an image with ASCII only characters, percent encode everything? It's just kind of a mess. And again, the browser won't let you. You can, if I try to modify this, well, that form will work. But if I try to modify this form and upload an image, the browser's not going to let me. So this is the format we'll be staring at for quite a bit of homework too. This is what you'll be parsing to get objectives 2, 3, and 4, and 5. I guess you're going to continue to use these in 5 when you add another input. And real quick, we'll cool down with just a few more inputs. Again, I'm not going to go through like every HTML element, but there are a couple just really quick things. It doesn't take long to show you, so I want to show a few of them. If you want radio buttons, this is the syntax for that. With radio buttons, you make each button, and those are the circle buttons if you haven't heard the term radio. Those are the circle buttons where you can only pick one of any of the options. When we do that, we give each input its own name of type radio, give it all the same name, and any of them with the same name, the browser's only going to allow one of them to be selected. And you give them each a value for the value that will be sent to the server. So if they select this button, on the server side, we're going to see some value named choose 1 with the value 2. Drop-downs, very similar. We're going to have some drop-down, which is, I guess it's not that similar. But with select, and then each option is going to have the same name, and each one has a different value. There's a couple, there's plenty of more. If you want to know how to build any type of form that you've seen online, W3 Schools has you covered. Let's see, you might have seen me messing with this before lecture. Let's try to get a very quick example. Oh, not that one. Oh, preview. Where am I? Bear with me just for a second. Plonk that here. Let me put a you know what, do I even want to mess with this? Yeah, I do, because I want to show you the... Oh my God. So I'm going to start a server. This server is just printing things to the screen. If anything goes wrong with this, I'm just going to cut this example short. It's just printing to the screen whatever's submitted. I'm going to open up my HTML. I need to look for the port here, 8000. Just whatever. I'm going to open this. Oh, come on. Give me an easy way to open this. Reveal and Finder. I'm just going to type some garbage. or my server responded with hello. That's good, something happened. And we can take a look at the requests that we got. So we got this as a multi-part form request. So I got a post request for / whatever path I set the form to. I got content length 242. Give me content type, multi-part form data with this boundary. And I can see that boundary appearing each time with 2 leading dashes and then the content type that I have. Now we can change that, which is what we've seen in the slides. And then we can change this. Ooh, actually, do we get just a partial request there? Ooh, there's a good answer. That's why you got to read content length. So I didn't get this, the full request all in one go. I wonder if that was more than, must have been more than 1024 bytes. Well, now I'm curious. Yeah, it has to be with all them headers. It has to be. So I actually didn't get everything in one go. So we'll talk about buffering next Monday, I believe. I didn't get the entire request because that's more than 1K of data that was sent in a single request. So there's a good foreshadow right there. But let me modify this HTML. Let me first get rid of my encoding type. Oh my goodness. Why can I not do anything today? Get rid of my encoding type. So I'm going to be back to URL encoded. And let me change this to file, which is something we absolutely can do. Send a PDF. It actually let me do it. The browser I expected to yell at me there. And let's see what we get. I'm actually curious what we do get. It shouldn't even allow that. So I'm wondering what we got. Oh, right. I completely forgot about that. It only sends the file name. It doesn't send the file, it just sends the file name. It's like, I don't know what to do with this. And just sends the name, which is useless information to us. I don't want the name of the file, I want the actual content of that file. And we don't get any information. I expect this to break, I just didn't know in which way. So it's really interesting how it's breaking. Then we're not getting all the information here. Not even getting to. Please don't do this on your homework. Yeah, and we're just getting that file name in our URL encoded content. But if we change this back, give me my multi-part form, change this to a file, reload that HTML. Now we're going to see what we get in what we'll be getting Wednesday when we have file uploads. Oh my. This is still a good foreshadow, but it's going to, is there an easy way to do this? I don't think so. But things are going to break. Whatever. It just stops. All right, well, I'll just verbalize it. Things are expected to break there, but I was hoping it would send us garbage in the terminal so I could say, look at all that garbage. So what we're trying to do is decode the bytes of a file as a UTF-8 string, which we know isn't going to work. And when we talk about file uploads, that's the big thing that we need to worry about. How are we going to parse these requests when the request has a mix of text and file byte information? So some of it can be decoded, some of it can't. And with a multi-part form request, we're even talking about some of this, like if this is the file, won't be able to be decoded, but everything around it can. Everything around it, everything else can. So how are we going to pick out that one piece of this request, this one sequence of bytes that we know we can't decode as UTF-8, and separate that from all the stuff that we can and almost have to, well, not have to, but should be decoding as UTF-8. So that's the big challenge that we'll talk about Monday. How are we going to piece apart that file from the rest of the content of the request? And with that, that's all I got today. So have a good day, and I'll see you Wednesday.